Okay, now question number 7. This question number 7 is different from other questions, little bit longer also, so it might be a tough question for you. So watch this video very carefully. Now, in this question, first we have to express this determinant as a product of two determinants. Then after that, we have to prove its value equal to this. So let us move towards our first part. First, a minus x whole square, a minus y whole square. Now here, use the formula a minus b whole square. So using that formula, it will be a square minus 2ax plus x square. And using the same formula here, you'll get a square minus 2ay plus y square, and similar for the others. Now, express each of these element as the sum of three numbers. So here is minus, so we have written here plus minus 2a to x and so on. And also at the same time try to express each element as the product of two numbers. Here it is a square, it is the product of two numbers, a square into 1, and minus 2ax, it is a product of two numbers, 2a minus 2x and x, and x square, it is a product of two numbers, 1 into x. Similar for the others. Now let us try to split this determinant into two parts, into two determinants. So in this type of question, remember very important thing, you have to focus on the diagonal elements, because these diagonal elements plays a vital role when we express this determinant into two determinants. And for the first element, okay, first look at this first element of the principal diagonal. So here a square into 1 plus minus 2a into x plus 1 into x square. So from this, first from this a square into 1, first give a square to the first determinant and 1 to the second determinant. Then from this minus 2a, you give minus 2a to the first determinant and x to the second determinant. And similarly, from the third part of this first element, give 1 to the first determinant and x square to the second determinant. Now leave these other elements and see this second elements of this principal diagonal. So here b square into 1. From this b square into 1, give b square to the first determinant and 1 to the second determinant. Similarly, minus 2b to the first determinant and y to the second determinant, and 1 to the first determinant and y square to the third determinant. Now leave the other elements and focus on the third element of the principal diagonal, c square into 1. From this c square into 1, give c square to the first determinant, 1 to the second determinant, and from minus 2c into x, z, you give 2c to the first, minus 2c to the first determinant and z to the second determinant, and from this last you'll give 1 to the first determinant and z square to the third determinant. And remember one important thing, while expressing this determinant as a sum of two determinants, in first determinant the variable must be a, b and c. In second determinant the variable should be x, y and z. Okay, in first determinant it is independent of the x, y, z term, and in second determinant it is independent of the a, b, c term. So you can check also a square for the first one. If you do row by row multiplication, then you'll get a square into 1, a square minus 2ax, x square, and from the for the second element b square, sorry, for the second element a square minus 2ay plus y square, and similarly for the other elements also. So now we had expressed this whole determinant as the sum of two determinants, delta 1 and delta 2, where delta 1 is this determinant and delta 2 is this determinant. Now we will move towards our next part. Our next part is we have to prove its value equal to this. Now for this, let us take first delta 1, the first determinant. So delta 1 is a square minus 2ax 1, b square minus 2b 1, c square minus 2c 1. So in next step, use the operation. Now try to make at least two elements of this row, column 0. So for this, use the operation on row 1 as row 1 minus row 2. So row 1 minus row 2 means you have to subtract each element of the row 1 by the corresponding elements of row 2. So a square minus b square minus 2a minus 2 minus plus, so 2b, 1 into 1 minus 1 is 0, 0. So in row 2 we are using the operation row 2 minus row 3. So we are subtracting from each element of the row 2 the element of row 3, corresponding element of row 3. So here b square minus c square, 2b minus plus 2b, and here 1 minus 1 is 0, and the third row remains unaltered. So here use the formula a square minus b square, so a plus ba minus b, and here b square minus c square can be written as b plus cb minus c, and from here you can take minus 2 common. So if you take minus 2 common inside bracket, your term will be a minus b, and you can take minus 2 common from here also. After taking minus 2 common, it will be b minus c, and all the term remains constant, the same. Now you can take a minus b common from the first row here, and b minus c common from the second row. So after taking this common, you'll get this term. And now without wasting time, expand this determinant through row 1. So when you express this determinant through 1, first write this element and it's minus this. Minus of minus 2 is plus 2, and it's minus this one, and 0 into is minus. 0 into anything is 0, so no need to write it as minus. Now first you have to go to principal diagonal, so minus 2, and this one is 0. So here, and for this determinant 2 into first you have to go to principal diagonal b plus c, so here b plus c. So now remove this bracket, minus 2a minus 2b plus 2b plus 2c, so minus 2c and plus 2c get cancelled, and from this if you arrange this and if you take 2 common, then you'll get a minus b, b minus c minus a into 2 times. So now let us move towards our next determinant, that is determinant delta 2. So delta 2 is this one. Now try to make at least 2 elements of this first column 0. So for that use the operation row 1 on row 1, and the operation is row 1 minus row 2, and in row 2 minus row 3. So here you are subtracting each element of row 2 by the corresponding element row 3, row 1 by the corresponding element of row 2. So 1 minus 1 is 0, x minus y, and x square minus y square. Now in row 2 you are using operation row 2 minus row 3. So each element of row 2 is subtracted by the corresponding element of row 3. So 1 minus 1 is 0, y minus z, and y square minus z square. Now here use the formula a square minus b square, so it will be x plus x square minus y square can be written as x plus y, x minus y, y square minus z square can be written as y minus z, y plus z, and you can take x1 common, x minus y common from the first row, and y minus z common from the second row. Now interchange rows into columns, so it will be 0 1 1 0 1 0 0 1 0 0 1 1 1 z 1 1 z, x plus y, y plus z, z square, x plus y, y plus z, z square. Now expand this determinant through column 1. So expanding this determinant through row 1, so this element will remain same, and 1 times of its minor is g 1 1 x plus y, y plus z, 1 1 x plus y, y plus z. And first you have to go through principal diagonal during expansion of this second order determinant, so y plus z minus x plus y. So minus, remove this minus sign, and this remove this bracket, minus x minus y, so plus y and minus 1 get cancelled, so z minus y. So after this the value of the second determinant delta 2 is x minus y, y minus z, and z minus x. Now since this whole determinant is the product of two determinant delta 1 and delta 2, and we got delta 1 as this one and delta 2 as this one, so after multiplication you will get that this whole determinant is equal to this whole term. So this is the proof of your question number 7.